you will start a little earlier, so I will control the time, okay? I will tell you 5 minutes, something like that. And we have the AeroPython guys, and they will tell us about how they analyze the flight safety data with Python. So an applause to them.
Can you hear me well? Yeah? Okay, okay, the name of the talk, as you know, is Remove Before Flight, Analyzing Flight Safety Data with Python. My name is Jesús Martos, and I'm going to be giving this talk with my friend Alejandro Sáez. A little bit of self-promotion. We're both aerospace engineers. We're both passion for programming, especially for Python and the Python community. And as you know, or maybe not, we're members of AeroPython, which is a group of aerospace engineers who developing Python tools. Okay. So what is the main objective of this talk? Throughout the years of our university, we've been seeing many figures and books and stuff like that. And once we felt comfortable programming, we wanted to reproduce those graphics with real data. So we found one database on the internet, and we started working with it. Okay, a little bit of disclaimer. We're not safety experts. That has to be very clear. We're not experienced data scientists, so maybe the question that comes to your mind is, what are these guys doing up here? The answer is very easy for us. We're very enthusiastic about Python and anything related with it. We're curious about anything related also to the aerospace field, so we thought this could be great for us and also for you to show you this, a little bit of this. Okay. Before starting with the programming, I'm going to show you a little bit of this topic, aviation safety, what it's all this about. Okay. Well, as you can see, flight safety has many stages, as much as the life of any aircraft. You can see, for example, the design that involves the manufacture of the aircraft, the manufacturing, certification. You can see it here. Maybe you think that the most important for a safety agency, I think you may think that is operation, but actually the whole process must be studied for this topic. It's not only operation that is usually the topic, the typical thought. We're going to be focusing on the last one stage, the accident investigation, because the database we have is from this last stage. Okay. Here we can see a little bit of the organization that studied this topic. There are many in the world. One of the most important is the ICAO that we can see here. It's part of the United Nations, and we're taking some definitions and some thoughts from this organization. We can see also the IATA, which is where all the companies belong to. And we can see American organizations. Here in Europe, we have the Eurocontrol that focuses on navigation problems, and the EASA, who focuses more on the safety problem. Also, every country has their own department from this topic. And here in Spain, we have the Ministerio de Fomento. Okay. So once we decided to do this talk, we wonder where we can find the data for this topic. And once we started looking for it, we realized that it was not easy. So we started thinking, why there is not so much data about this? And the reason is that, well, obviously it's not an easy topic to talk about. And also there are some rules, let's say, that every time that an accident occurs, the investigation must be done, but the publishing is not mandatory, at least not the detailed data. So there are some countries that provide that data, and there are others that don't. We are happy that the United States provide the data, and those are the data that we're using in this talk. Well, we're going to be using Pandas that, well, most of you know because there has been a lot of talks with it. And if you are an expert of Pandas, I hope you enjoy the safety part. Yeah, and as I said before, the main source for the data is the National Transport Safety Board from the United States. And that's from where we get the database. Well, anything related to this agency is great. Not only the database, anything is public, and the reports are fantastic. So let's start programming. His computer, so.
It's my fault then. Okay.
Okay, let's start importing. Okay. Okay, so let's take a look at the database without any filter. The important information to follow properly the talk is that we can see that any accident has an event ID, and we can also see the different information that this database provides. We can see where the accident occurs, for example, when or how was the weather, anything. Okay, so So after this, one of the data that was very important for us was the date. We realized that it was a little bit difficult to work with, so we parsed it. Okay. And here, we can see we start with the problems that any real database can have. So this database is supposed to start in 1982, but we can see here that there are 6 accidents before that data, so we removed them, of course. Okay. So now we start filtering the database. We want to focus on the typical flight that any of you or me can take. So the first classification is about the type of event. We have 2 types, basically. One is called an accident, and one is called an incident. For you to know, the main characteristic of an accident is what you can read here: when a person is fatally or seriously injured, or where the aircraft sustained damage or a structural failure, or where the aircraft is missing or is completely inaccessible. We're going to be focusing on the accident, not the incident. Okay. So we can see that we have more than 70,000 accidents. Okay. And now we've discarded the incidents, and now we're going to focus on, as I said before, I want to show you some flight that is very common. So the flight you can classify in many different ways by the model of the engine. So the way we've done to get the flights we want is we're going to be focusing on a classification that a specific agency takes. We're going to be taking those which are called Part 121, that are the big aircraft with revenue commercial aircraft, and the non-US and commercial aircraft. So we do this in Python. We can see the different far parts. Okay. Okay, one of the main methods we're using here in this talk is this one, because the problem is that the database is there are many tables. It's not one only table. So in order to work with one table and another, we need some criteria to get from one table and go to a different table. So we've done it with this method, which is very useful. Okay. So until now, we've done 2 filters. We've taken the accidents and the big aircraft, the aircraft that are not glider, not balloons, only big aircraft. So after that, we can see the different parts here, and we can see that we have 1,573 aircraft. However, we see that we still have helicopters and now. We don't want that. That is because maybe in some accident they were involved in helicopter and an aircraft, so they appear here when we don't want. So we take that out. Okay. This is the number we have. This is the memory we're using, 3.6 megabytes. It's big data. Okay, now the first part of the filter of the database is done. Okay.
Okay. So now that we have loaded the data, we are going to perform some analysis, and we are going to try some of the questions you may be wondering. The first thing we are going to do is, okay, I wanted to use base map. I've been wanting to do that for a long time, and now I had a lot of locations in a database, so it was maybe a good idea to plot where do accidents occur. So what information do we have about location in our table events? We can see we have the name of the city, the name of the state, the country also, and we have some information about latitude and longitude, which we cannot directly use because someone had the idea of storing it as hours, minutes, seconds, plus north, south, east, west. So the first thing we have to do is to parse it. We have some functions to do that based on regular expressions and the conversion from hours to minute and all of that. And after that process, we can find that there are more than 1,000 events with no location at all. I don't know if you saw that before, but after the filtering, we will be working with, here we see, 1,500 events. So almost no event have information about location in terms of latitude and longitude. As I really wanted to use base map, and I couldn't plot just 40 points or something like that, what I did is using Google Geocode API. Sorry, I'm a little bit lost here. Okay, here. So as we had the information about the city, the state, and also the country, why not sending that information through the Geocode API to Google and then take the longitude, the latitude and longitude. This is done in another notebook. We'll do the pull request to the main repository of the conference, and you can see that there. There's also a restriction on the number of queries you can do every day and the queries per second. So as we wanted to be trying, I couldn't do that live, and it would take some time. So I have the data loaded into another table. This is the table I'm constructing to send to the Google API Geocode. As you see, I have information city, country, state, sometimes about the state, not always. And once I send it there and load it here again, there are only 44 events with no information in terms of latitude and longitude. So now we have the information. Let's plot and see what happens. It takes a little bit of time. Okay, I don't know if you see something there, but our main conclusion here was, okay, they are not lying, the database is American. Okay, you can see there are some clusters that there are places where no accidents occur. I mean, let's focus on the states. And as you, and I think you guess, it's related to the amount of traffic. So we got some information about airports from another data source. You have all the data sources in the repository also. And let's try to plot also the airports. Yeah, this takes a little bit. Okay, there we have it. So in the upper part, you can see every airport in this database. And in the lower part, we can see again the accidents. And we see as the accidents concentrate around the airports or even inside the airports. We'll talk about that a little bit more when we see the causes of the accidents. Well, not the causes, the occurrences. Okay, another question is, I'm taking my flight, which is, what is this? When do accidents occur? Are they likely to happen in every phase of flight? Okay. Just briefly, the flight starts with the plane parked, then you go and taxi to the runway. Once you are in the runway, you take off, you have a phase of climb, then you reach the cruise altitude. This is the most part of the flight. At some point, you are near your destination, so the pilot put less power on the engines, you start descending, and we have a phase of approach to the airport, and finally, the landing. Normally, the phase of the landing starts with the plane really, really close to the ground. It's not what people normally calls landing. What people calls normally landing is approach plus landing. So take this into account when we are plotting things. The database is really detailed, and it doesn't only make the distinction in landing, approach. There are different phases in landing, for example. So what we are going to do is to group them all in a general flight phase called landing there. And this is what we are doing here. Okay, obviously it doesn't say landing in the database. There are some codes. So what we are doing is to translate that codes into something meaningful with the help of the documentation about that database, which is also really good and really well documented. Well, I'm saying it's well documented. Right at the same time, I'm going to say that we were looking for this 0, and there's no information at all, or at least we were not able to find that. So we are a little bit curious about that. Okay, so which flight phase is safer, or when do accidents occur the most? We can see there are many accidents relating to landing, but if we add up also the approach phase, there are even more. So we would say that's the most dangerous part. People is normally right when they are afraid of landing and taking off. I mean, they are not right, but it's the most it's most likely to happen there than in any other phase of the flight. We find also here takeoff. People normally grab the seat during takeoff. And we were surprised to find here taxi and standing. Standing means the plane is just stopped. So something happens suddenly there, maybe fire, maybe another plane passing by and touch your plane. This is considered an accident, even if no one results damaged or injured. But it can, as we were showing firstly in the definition, if there's major damage in the plane, as could be the case, I invite you to, we didn't want to include pictures or something like that, even if it's just for the plane, but you can Google for that. And sometimes one is like a car crash, but inside an airport. And they just touch with the wings, in the wingtip or something like that. It's not really dangerous, but it is considered an accident. And it occurs. So we've seen that there are many accidents, and I was telling you, okay, let's have a look at the number of injured people, the number of fatalities, or also the damage to the airplane. Okay, I will pass by this quickly. So we construct this table based on the information from some other tables on the database. And we can see by flight phase the damage to the aircraft, which is none, substantial, destroyed, minor, or unknown, and the number of injured people and fatalities for that flight phase. Okay, this, oh, I don't want to do this again because I duplicated everything. Now. Okay, so maybe it's better if we plot it. We see it's pretty straightforward to plot all the data contained there with Pandas, and we were really happy to see that. We knew very little about Pandas when we started, but I think we've learned a lot, and we found it difficult at the beginning, but then we discovered this kind of tools, and it's wonderful. So, okay, going again to answer our questions, we see a large amount of events during landing, and we see that normally the aircraft experiences substantial damage during landing. It results destroyed or substantially damaged. It is the same more or less during takeoff, also the approach phase, what we are calling wrongly landing normally, again. And, well, however, there are other flight phases, for example, in cruise. The aircraft normally doesn't experience a lot of damage. What happens here? We'll see the number of injured people and explain this there. But it could happen, and we'll see an example, that you are sitting on your seat in the airplane, and the seatbelt sign is not turned on, so you decide to do like this, and suddenly something happens, turbulence or a hard maneuver, the pilot does like, and you fly. Yeah, okay, it happens, and it results in injured people. Normally, it's not passengers, but flight attendants who are passing by the corridor, the aisle of the plane, result injured a lot of times like this. So, okay, let's look at what happens to people. This is plot in the same order as before, but let's order by the number of fatalities. And we see takeoff is the worst one. If something happens there, the airplane is really close to the ground, the maneuver margin is low, let's say, the decisions have to be made really fast, so it's critical and normally dangerous. Also, the plane has a lot of fuel inside, so it ends up with fire, and that causes a lot of fatalities. It happens more or less the same. We see the big blue bars for the approach and climb phase. However, let's have a look at landing. Injured people, we can find more injured people than fatalities. So, okay, it's really, well, it's not really probable. It's most probable that something happens during landing, but in case that happens, there are more chances that you survive, which is good to know also. Okay. So let's have a look also at the main accident occurrences. We decided to call it occurrences because it's called occurrences in the table, but I'm going to explain you a little bit more. For this event ID, we can see here, let's check what information we can find in the occurrences table. The very first thing we can see is that there were 2 aircraft involved. We have aircraft key 1 and aircraft key 2. So there were 2 aircraft involved in this accident. And there are several occurrences. Again, we identify each occurrence with a code, and I will explain you now a little bit of these codes. So we can see that there's not like a one cause for each event. It's just a sum of things. We were curious about this case, so we got more information for it. We entered the ID in the events table, so we can see it happens in 1985 in South Haven, the United States. And we also decided to look for the report, a brief report of the... Okay, this is the National Transportation Safety Board webpage. We can look for reports of the accidents, and we can have a look there, what happened there. There was a big airplane, a Boeing 727, flying. It was starting the descent phase. The seatbelt sign was turned on. Okay, and there were some clouds. So suddenly the pilot of this big airplane saw another aircraft. It was a little aircraft descending. Okay, okay, you are quicker than me. So he saw that and suddenly maneuvered hardly. This resulted in some flight crew injured with that and significant damage in the little airplane. They didn't collide, but experienced significant damage. So, okay. Again, we are filtering the occurrences. The classification is really detailed, so we are grouping them in bigger groups. These bigger groups are the ones you can see here: fire, explosion, forced landing, GR collapse, hard landing. The difference between forced landing and hard landing, for example, talk a little bit about it. Forced landing is that you need to land in an unexpected place. It's not your final destination, and it's a place that you are forced to choose because of major circumstances. A hard landing is, let's say, you lose a little bit the control of the airplane. It's not a loss of control. It's like you go against the terrain harder than expected, or that kind of things. So once we have these occurrences here, we again plot the number of accidents, the number of times it appears. Again, it's not the main cause. It's just that this happened. And we find that encounters with bad weather or unexpected weather for that flight phase are present in many, many accidents. Also collision with objects, even on ground. This is what I was talking about at the beginning. We have also collision in flight collision, which is less common, fire explosions, loss of engine power, okay? Many people think the worst thing that can happen there in the air is that you lose one engine, maybe two of the engines, or maybe all if you have four. Okay, obviously, it's not nice if that happens. But I have to say it's not the worst thing that can happen. Yeah, gliders fly without engines. There's no problem, they fly. You go smoothly down. You have time to react. If you are at a height enough, you won't have much problems. I mean, it's not nice, it's not normal, it's not expected to happen, but if it happens, and in many other flight phases, even during the takeoff, you have to certify your plane to take off with just one plane, with just one engine from a certain point of the taking off, at the taking off. Okay, so we are discovering some interesting data here. Another question you might be asking is, what impact does experience have? I mean, we are going to evaluate experience in terms of age of the pilots and also in terms of flight hours. Let's start with age. We have this information available in this database called Flight Crew. We have information about the age, sex, residence country. Even the profession was over there, which is funny, because it's a pilot. Okay, not for general aviation. General aviation was contemplated also in this database, but we filtered, and we've gone only to commercial revenue aviation. Okay, as always, we have some problems with data, with a lot of blanks, spaces, and all of that. We filter, and let's have a look at the age. The mean age of pilots involved in accidents, it's 44 years, the minimum 20, and okay, maybe this box plot can tell you more. 50% of the pilots are inside this box, so this is between 37 years old and 45 years old. So let's plot now in groups. Once we see this, we would be tempted to say, okay, so pilots between, let's say, 45 and 55 have more accidents than the others. Okay, no, we are not experienced data scientists, but we know we have to non-dimensionalize this data. Let's say we have to take into account that the majority of the pilots flying are in that age. How we did that? Okay, we went to this source of data, is compressed data inside a PDF. And we extracted the values of the number of licenses for pilots last year, in 2015. So we will assume for this analysis that the number of licenses, or at least the distribution of licenses in different groups of faiths, has been the same since 1982 to now. We have checked this a little bit, and it hasn't changed a lot. But anyway, I let you know that we are making that assumption. Once we do this, we see that our young pilots, the one having more accidents. We wanted to be cautelous with everything we were saying here today. I mean, the first thing we said is we are not experts, but okay, we can do say whatever and say, okay, there you are. So we checked a little bit, and we found in this handbook of aviation human factors that some people had been investigating this before with similar results. It says pilots with the same rating who are aged between 24 is the, well, okay, I'll let you read. In the meantime, I'll come here. It says that young pilots experience, between these age, 20 to 24, experience 3 times more accidents than pilots in this group. If you are checking also the numbers, you will see that they are not the same. The reason is obvious. We are not non-dimensionalizing with the same curve because we were not able to know which curve they were using in this book. But okay, we are reproducing the result. I was telling you that we were also going to evaluate the influence of experience in terms of flight hours. I won't go into much detail. I will explain you better here with this widget. Okay, let's see. I'm going to move this first. Sorry. Well, we can first differentiate. Well, we have a lot of information here about flight hours. We were really surprised. This is a lot of information. I can check, for example, the number of hours in multiple engines that that pilot has. In simulator, single engine. Make, which is going to be the model that he was piloting when having the accident. Rotorcraft, lighter than air, all, gliders, lots of information. And not only that, I can get the totals, but I can also get last 24 hours, last 90 days, last 30, as a pilot in command. Okay, so this was really surprising. Let's check, for example, multiple engine and something like last 30 days. Last 30 days. Okay. Well, let's look for a funnier one first. Multiple engine, last 24 hours. We can see that there was a pilot who flew for more than 60 hours in the last 24. This is strange. That's why I have this slider here, so I can filter a little bit, and hopefully I find 24 hours. So, is it working? Yeah. Well. Okay, now this is, okay, it's working, but the first data is here. That's why it wasn't moving. So this is the number of flight hours for during the last 24 hours in multiple engines that pilots experiencing an accident had flown. Let's go to something more meaningful. For example, total in multiple engines. And here we start seeing that pilots with less flight experience have more accidents than pilots with more flight experience. We can also go to the model, okay, and it's even clearer, even more clear. And we could also take instruction, sorry. No, not instruction, simulator. Okay, so formation and experience is important. And how do they promote this? I mean, normally you have a co-pilot, less experienced, then you have a pilot, more experience, they learn from each other. Each one has different abilities. Maybe a younger person can handle the aircraft quicker in some situations, but when it comes to take decisions, it's important that someone experimented, can make them. So, finally, is commercial air transport safer now than 30 years ago? We hope to say yes. This is the graph. Here we are seeing the number of passengers. This is the number of fatalities in red. We see that there's a peak here and then it descends. But again, we have to non-dimensionalize this data. We need to know that air transport have been growing a lot the last year. This is million of passengers transported. This is million of flights. It's funny if you have a look here. Oh, no. No, it's not funny. Sorry for this. No, you're not dead. Not dead. I don't see. Okay, so I have it there. Can I move? Okay. So it has been growing, and now we can see that have larger airplanes because there are more passengers, and also that planes are less empty.
Can you increase the size of the font a little?
Yeah, but it's difficult because I'm not seeing anything here. Okay. Okay, so now here I have, I can see very well, the fatalities rate. This is dividing the number of fatalities with the number of passengers transported. And we were surprised that everyone is always showing this part of the graph, and they are telling us that flying is safer now than before. But what happens here? And we are curious about that. We don't have much time to perform the investigation about it, but for sure we'll do it. Because we discovered, when we saw that, we were like, normally we don't see this, but we went to the plots and saw that everyone is showing this part. Of course, the very first thing we thought is, you are doing it wrong. Don't say others are wrong. First, check a little bit. But we check against the FAR report, and because of the non-dimensionalization of the data, not the non-dimensionalization. We are using different data to non-dimensionalize, so the number is not the same, but we have the behavior. So we think we are doing it well. Just to summarize, this is the structure of the database. Some quick conclusions. We were telling you that it was difficult to get the data. In Europe, it's not publicly available, or at least we were not able to find it. But we are doing well, I think, in data gathering. There's a little bit of mess. I've been reading their reports, and they are concerned about it. I extracted some quotes. And it seems that they want to do it well. I hope they are. And at some point, release the data available to everyone. And some other conclusions, data analysis is not a bed of roses. It's cool, it rocks, but getting the data is hard. Thank you, NTSB, for that data. Cleaning it is time-consuming. We had to parse a lot, we had to play a lot. It took a long time, but we learned a lot. And also, Pandas help a lot. So thank you very much.
Are you any more afraid of flying than before? Good. Questions? You're
really scared, I guess.
Being having seen more time series maybe than you, the spike you say that you have, that curve is very intermittent. So it's that much intermittent that maybe there's not a further cause in those 3 years. So the curve is going up and down all the time. So maybe it's a coincidence. You can never tell.
Yeah, you are right about that, and we've been checking many other reports about safety. They sometimes do a trick. It's not a trick, but you have to read carefully, and they perform moving averages and that kind of things, and that's maybe why we hadn't seen that before, because we were not paying enough attention to the small letter.
Really, when curves are wiggling a lot, you may find yourself saying, I can't tell. Coincidence, whatever.
Yeah, could be.
Thank you very much for your presentation. Okay. Are you going to make some correlation with the data that you gathered with the security procedures that are taken in each step of the flight? For example, you say that the most frequent incidents were in takeoff and landing, and I think that's the most well-procedured security in the steps of the flight. So it's like doing a de-aggregation of the results in those, taking into account the security procedures.
Okay. If I get paid for that, I'll do it. No, okay. It would be really nice, and we've seen that we have a lot of data available, a lot of things. There are a lot of things that we can do. But we've also discovered, and again, that it's really hard dealing with real data. You have to clean it. You have to get it first. I mean, it would be difficult to establish a well-based methodology to do that. You have to be really careful. I don't know. I don't know. Any more questions? Like we have time?
We still have time for a couple of questions. Make a couple of questions because the coffee break is not ready yet. So. No? So coffee break. Thanks to speakers.